Okay, so we're going to look at exponent laws today. So the first part of the exponents law we have seen before in grade 11. Then the ones that we're going to learn in the next lesson are going to be new ones. So a power is an expression made up of two parts, as we said before. It's the base and the exponent. Okay, it's important to be able to identify the base and the exponent because you're going to have to know if your bases are the same or not. Okay, so let's first look at these examples and let's identify exponent. So if I'm looking at 5 to the power of 4, I have a base of 5 and exponent of 4. How about negative 5 in brackets to the power of 4? What's my base? Negative 5. And my exponent is 4. X to the power of 3. X is my base. 3 is my exponent. Okay? Now let's look at 7 to the power of negative 3. 7 is my base. And negative 3 is my exponent. How about the next one? Negative 5 to the power of 3. What's my base? It's not 1 over 5 and it's not negative 5. I'm not asking you what the answer is. I'm asking what is your base?
Minus 5.
It is not minus 5.
5.
5. Why is your base 5 in this case and not negative 5? What's the difference between this one and between this one? This is bracket. So inside my bracket, so that means my whole base is in that bracket. So that negative 5 is my base because the whole negative 5 is to the power of 4. In this case, it's only the 5 that's to the power of 3. Okay? So my base here is 5 and my exponent is 3. What would be my base for 3x to the power of 3? 3x, because the whole thing is inside the bracket. Okay? So my exponent, my base is 3x and my exponent is 3. So as you guys know that a power, it's a repeated multiplication of the base an exponent number of times, right? So when I say 5 to the power of 4, that's 5 times 5 times 5 times 5. So I'm multiplying the base by itself, exponent number of times. So whatever, how many exponent is that? So in this case, if I have negative 5 to the power of 4, what would be my expanded form? It's negative 5 times negative 5 times negative 5 times negative 5. What if I have this? How would you write that as expanded form? With a negative in the front, right? So you'll have a negative in the front. That represents this negative. And then you'll have 5 times 5 times 5 times 5. Okay? So you see I only have one negative, which is at the front, and then 5 is my base, so 5 is multiplied by itself 4 times. Are we good with that? So you see the difference between this notation and this notation, the negative 5 in brackets. You see the difference?
Okay, you're saying if it's not in bracket, right?
Yes.
Okay.
All right. So if I have exponent on that x. So if you're looking at this x, what's the exponent on that x? It's 1. So if you don't have an exponent, it's an exponent of 1. So x is the same thing as x to the power of 1. 2 is the same thing as 2 to the power of 1. So you guys have to be able to recognize this. You have to be able to understand this. Because when we use the exponent law, you're going to have to recognize that there is an exponent there and it's a 1. Okay?
Maya?
Yes.
Sorry. Going back to that negative 5 to the power of 4,
Yeah.
if it's not in bracket, right?
Yeah.
The negative sign stays just one time
Yes.
with the base. Number of times raised to the exponent.
That's right.
Okay.
So you remember that your base is just 5,
5, yeah.
but it's multiplied by negative 1.
1.
Okay, so it's you can see this as I have a negative 1 multiplied by 5 to the power of 4. This is what you're gonna see when you look at something like this. Okay, so you're seeing that it's a negative 1 multiplied by 5 to the power of 4, which is 5 times 5 times 5. Okay, and it's very important to understand the difference when you're putting it in the calculator, right? You should know that this answer is gonna be a negative answer, right? While this answer, because I have negative, negative, that's positive, negative and negative, that's positive, so my answer here is gonna be positive. So if you're not sure if you need to put bracket or not, at least you need to know which answer is gonna give you negative, which answer is gonna give you positive. I personally don't even bother, right? I know that my answer is gonna be positive here, I don't even bother putting that negative there, okay? I know that my answer is going to be negative here. I don't even bother put that negative. I just put 5 to the power of 4 and I put a negative outside. So it's just you knowing what the answer is going to be. Don't let the calculator command you. You command the calculator. You know what your answer should be. Right? So we're going to start with the first exponent law, okay? These are review from grade 11, so if you took grade 11, you should know these things. So multiplication law. So when I multiply powers with the same base, I'm missing an E here. So remember that word same base. If you don't have that same base, you can't do this, okay? When I multiply powers with the same base, what do I do with the exponent? I add the exponent. Okay? So, let's look at this example. I have 5 to the power of 5 times 5 to the power of 4. Do I have the same base? Yes. What is it? 5. My base is 5. So, I keep my base and I add my exponents. So that's going to be 5 plus 4. So my answer is going to be 5 to the power of 9. Okay? So it's important that you have the same base. Otherwise, you cannot perform this method or this operation or this law. How about the second example? So you have 2x times 4x squared.
2 is 4, then x to the power of 3.
So 2 times 4 and x to the power of 3. Yes, you can do it this way. But what if I ask you to write them to the same base? Can you write them to the same base?
Oh, yeah.
What is it?
4 to the power of 3. 4 we can write it.
I can't understand what you're saying.
4x to 2x and 2x, and we have
So you're telling me that 4x squared can be written as
2x and 2x.
2x squared,
No, 2x and
2x
2x.
squared.
which is 2x squared.
Yeah.
2x all squared. Right? So if you're writing this, the 4x squared as 2x times 2x, right? That's the same thing as writing it as 2x squared, no? Yeah, okay. So yes, if you look at this, 4x squared, right? That's the same thing as writing it as 2x squared, right? Now, if you guys want to do it, whatever you told me before, multiply the 2 times the 4, right, which gives you 8, and then x cubed, that's totally fine. You can do that, okay? But I also want to show you that you can write them to the same base. Now, you see that I have the same base here? what can I do with my exponent?
Add it.
Because I'm multiplying here, right? My exponent here is 1. So that, the answer for this is 2x to the power of 3. Right? If I actually want to do the math here, and I want to expand this, what would your answer be for this? 8 x cubed. Is that what you guys got when you just did the 2 times the 4 and then x? Yeah. Okay? Okay, so if we have the same base, we can add the exponent. Then we can, as you can see, I was able to expand here, right? We'll talk about expanding in a bit. That's another law. Now, if I'm multiplying, I can add the exponent. If I'm dividing powers with the same base, then I can subtract the exponents. Okay? Remember, the trick here is that you must have the same base. So, you have the example here, negative 6 to the power of 10 divided by negative 6 to the power of negative 2. So what would be your answer for this one? Do I have the same base? Yes. So I keep the base. What do I do with the exponent? Subtract. So I have 10, subtract negative 2. Right? You're subtracting a negative 2. So if you're subtracting a negative, what does that give you? A plus. That's right. So that's 10 plus 2, which is 12. Okay? Common mistake is students forget that when they're subtracting and there is a negative, minus and minus makes positive. Okay? How would you simplify the next one?
Divide the 6 by 3 and the 3 by 3. So 1 over 3.
1 over 2.
2
Yeah.
I mean.
Okay, so both of these are divisible by 3, so I can simplify this, and that becomes 1 over 2. Okay?
X.
So what do I do with my exponent for the x? Okay, so you're subtracting the 4 and the 2. Okay, so that's 4 minus 2. And then how about the y? 5 minus 1. Remember, if I don't have an exponent, it's an exponent of 1. So my answer for this is going to be 1 over 2 x squared y 4. So I take the bases, the common bases, and I subtract their exponents. Okay, again, all of these are review from grade 11, so you guys should know all of this. And then the next law is power of a power law. So when an exponent is raised to another exponent, what do I do with that? I multiply the exponents. So I have 3 to the power of 4 to the power of 5. So that's 3 to the power of 4 times 5, which is 3 to the power of 20. You technically don't have to write that middle step right there. I'm just writing it for you so you know what's happening. Okay? But you can skip that that step, which is the 3, 4 times 5. Okay, can we look at the next example? So I have negative x to the power of 3 and then to the power of 7.
1 over x to the power of.
Why 1 over x?
negative x to the power of 21.
Mhm.
21.
So, remember guys that in this case, it's going to be negative x to the power of 21. Because that 7, it's an odd number, right? Negative 1 to the power of 7, it's going to stay negative 1. Important. Okay? So what if my question was negative x to the power of 3 to the power of, let's make it 6. How would that change things?
So we multiply the number of times. 6 times. Multiply the negative x.
Okay, so what does that mean?
If you multiply a negative and a negative, it becomes a positive. So if you have pairs, then you'll be left with positive. If there's an odd number, it'll go back to negative.
That's right. So in this case, my answer is going to be positive because I have it 6 numbers of times, right? So my answer for this one is going to be x to the power of 18. It's going to become positive because I'm raising that negative to the power of an even number. Do you guys remember that? Okay? While in this case, because I'm raising it 7 times, right, which is an odd number, negative times negative makes positive, times another negative, that's a negative, times a negative, that's a positive, times a negative, that's a negative, times a negative, that's a positive, and then times another negative, that's a negative. So if you're raising it odd number of times, it's going to stay negative. But in this case, I'm raising it even number of times, to the power of 6. So that's why it's going to be positive. Okay? So you have to be careful when you're giving your, when you're writing down your answer for something like this. So, 3 laws so far. If you're doing multiplication law with the same base, you add your exponent. Division law, with the same base, you subtract your exponent. Then power of the power, you multiply the exponent. We're going to move to the power of product or quotient law. So, to simplify a power of 2 or more items multiplied and or divided. So if I have 2 or more items inside my bracket that are multiplied or divided, I distribute the exponent of each item being multiplied and or divided. So, what that means is, you're going to, you see how you have power to the power earlier, and then what we did, we multiplied the exponent, so that's x to the power of, in this case, 12, right? But in this example here, it's not only x to the power of 4 that's raised to the power of 3, it's also that negative 3 that's raised to the power of 3. Okay? So every single item inside the bracket is raised to the power of 3. So what would that give me here? Negative 3 to the power of 3, and then x to the power of 12. Okay? So that power of 3 also affects that coefficient that we have here. Okay? Let's see why is that. Why that exponent is affecting that negative 3 as well? It's all inside the bracket. So if I want to expand this, how would you expand this? If you want to write this in an expanded format, how would you write it?
Minus 3x1.
Yeah?
Times minus 3x4 times minus 3x4.
Right. No? Which means I have negative 3 times negative 3 times negative 3.
Negative 27.
And I have x4 times x4 times x4, which is x12. Right? That is why. That's why if I actually do the math here, negative 3 to the power of 3, that's negative 27, x12. Right? Now this was easy here to actually to expand because it was only 3 times, right? But if I had this to the power of 10, do you want to really write this as 10 times and then do the multiplication? No. So it's better to know the rule, okay? That anything inside the bracket is going to be affected by that exponent. So that's the case if I have multiplication, which I already know that it's multiplication here, right? And then if you have division, that's why we call it quotient, okay? So what would you do here?
First one.
So 4 is going to be squared. Yeah.
Y 5 times 2.
Y 5 times 2, which is y to the power of 10. Okay.
Over 6 and 4.
Be
No,
careful there.
6 squared, sorry.
6 squared,
Yeah. Then x 4.
x 4. So every single term inside that bracket got affected. Okay? Now I can simplify. I can do simplification. So 4 squared, that's 16, y 10 over 36, x 4. Okay? What if you want to simplify this, what would you do?
Divide 36 by 16 and 3.
Can you divide 36 by 16?
Yeah, comment that.
What is it?
That's 4.
6.
Yeah.
36 divided by 16 is 6.
Ah, no.
4, I think.
No, we can simplify
four.
Okay.
36 and divide 16 by 6.
What can you divide both of them by?
4.
4.
3.
You can divide them both by 4. So your common factor is 4. So if you divide this by 4
Is 4.
and divide this by 4,
Is 9.
9.
9.
Okay? So you see that this is the most simplified form. Well, that should be x to the power of 4, not x to the power of 4.
Right?
Yes.
You don't understand.
Okay, do you guys have a calculator?
Yes.
Okay. So in your calculator, if you put any number, like just think of a number, doesn't matter what it is, put it in, as long as it's not negative. Just don't put a negative. Okay, you're done? And then put power of 0. What do you guys get?
1.
All of you got one? No matter what number you put in?
916 is 4.
Right. What number did you put in, all of you?
916.
916?
916.
960 to the power of 0, that's 1. What did you put? 56 to the power of 0 is 1. What did you put? Chico?
915.
915 to the power of 0?
1.
1.
Anything to the
Right?
power of 0 is
And this is not a coincidence. Okay? That no matter what number you put in to the power of 0, it's going to be 1. Okay? So, this is what we call the zero exponent law. Anything to the power of 0 is going to give you an answer of 1. Okay? Numbers, letters, negative exponent, positive exponent. This is all going to give you a power, an answer of 1. So you see this whole thing here, 3x squared, y to the power of negative 6, all to the power of 0? Without doing any math, the answer is going to be 1. Three to the power of 2, to the power of 4, to the power of 0. If I multiply all of this, that's going to give me 3 to the power of 0, no? Because 4 times 0 is 0, 2 times 0 is 0, so that's going to be still to the power of 0, which is an answer of 1 again. So why is that? We talked about it last semester. Why is that? Why anything to the power of 0 is 1? What's the relation there? Okay, let's look at an example here. If you have x to the power of 3 over x to the power of 3, what is that? 1, right? Because anything you divide by itself is 1, right? We know that. We know that if I have 100 divided by 100, that's 1. If I have 1,000 divided by 1,000, that's 1. Anything I divide by itself, it's going to give me 1. Letters, numbers, whatever it is. Okay? So if I have this, that's going to give me 1. Right? Because it's going to simplify to 1. Now, if I'm going to ask you to use the exponent law, since I have a division, what do you do with the exponent?
3 minus 3.
So you subtract, right? You keep the base and then you subtract your exponent. And what's 3 minus 3? 0. But I already said that anything that this answer is going to be 1, right? So that means x to the power of 0 is equal to 1, right? All what I did is, in this case, I did it in the old-fashioned way, right, where I'm simplifying. In this case, I'm using my exponent law. And this is going to happen every single time you have the same base with the same exponent, right? So if you have 5 to the power of 7 divided by 5 to the power of 7, that's going to give you 1, right? Because it's the same number divided by itself. If you're going to use exponent law, it's going to be 7 minus 7, which is 5 to the power of 0. Again, 5 to the power of 0 is equal to 1, right? That is why anything to the power of 0 is equal to 1. Okay? Do you have to show me all this work? No. Anything to the power of 0 is 1, and that's all what I need from you. Then we're going to move on to the negative exponent. So any base raised to a negative exponent, and not if it's negative, raised to the negative exponent, is equal to the, what do we say? Is equal to what?
Inverse.
Inverse or reciprocal of the base raised to the same positive exponent, right? So let's look at this without looking at the examples that we have here, right? So if you have, let's say, x to the power of negative 3, that's the same thing as 1 over x. So I reverse this, I reciprocal this, and then make it to the power of positive 3. Okay? Any negative exponent, you flip your base. Remember that my base here, any number or any letter with no denominator has a base of 1. What if you already have a fraction? So you have 1 over 5 to the power of negative 2. Flip to the power of 2. Okay? Flip the base, make your exponent positive. Okay? So if I look at my first example here, so I have 3x to the power of negative 4, y to the power of negative 3, and z.
3z.
Why are you bringing the 3 down? Is the 3 to the power of a negative exponent as well? No. So I have to leave the 3 on top. Okay? Common mistake. Okay? And that's why I want to hear from you first. Okay? A lot of students think that, well, if this has a negative and this has a negative, that means I'm going to flip the whole thing. No. you only flip the ones with the negative exponent. Okay? So in this case, the one that has the negative exponent is the x and the y. The 3 and the z are not raised to the negative exponent. So I have to leave the 3 and the z on the top, and I bring the x and the y to the denominator. Okay? So that becomes x to the power of positive 4, y to the power of positive 3. Okay? So you're only looking at the terms, or at the letters, or at the variables, or the numbers that have the negative exponent, and these are the ones that you're going to bring down to the denominator. Okay? Now, what if I have this? Okay, one at a time, please. One at a time. One at a time. One person, not all of you talking at the same time. So you want to bring the z to the top because it has a negative exponent and it's at the bottom. You have to switch its location if it has a negative exponent. So if it's in the bottom, you bring it to the top and make it positive. Okay? You switch its location. So that's 2y. 2 and the y, they're not going to change because they're positive and they're happy. The z is going to come up to the top with a positive exponent. And then you're going to bring x to the bottom. And it's going to be positive too. X. So this is the summary of all the laws, right? They're on the wall for you as well. Same base, multiplication, what do I do with the exponent? Add your exponent. You keep the base. You don't change the base, guys. If I have the same base and there is division, what do I do with the exponent? Power to the power. Anything to the power of 0. 1. Distribute the exponent, so it's gonna, the m is gonna be to the power am and bm. How about a to the power of negative m? 1 over a to the power of m. How about a over b to the power of m? am. And then if I have a negative exponent, flip the base, make your exponent positive. Then you can distribute, but I'm going to leave it like this because all what I care about for this law is that you're flipping it. Okay? Okay, so here's what you guys are going to do. You're going to practice these questions. And then make sure that you leave your answer with a positive exponent only. So if you end up with a negative exponent, you're going to have to make it positive. Okay?